Hey guys, Mr. B here again, and another topic that we discussed in Unit 4 was simplifying rational expressions. And here's an example that came from Common Exam where we're adding rational expressions. So again, one of the things we look for first with rational expressions, if they're possibly, we can factor them. So if we look at this x squared plus 2x, we have a common factor here. It's a common factor of x. So what we have to do is we first have to factor out an x. So we go, so take x outside the brackets. And what we're left with here is just an x in this one, and we're left with 2 in this one. Okay, so one way we can check whether we factor right is to distribute back through. So I get x times x, that's x squared. X times 2, that's 2x. All right, so now we're at this stage. So what do? Well, it's just like adding fractions. If you have two different denominators, you have to find a common denominator. So I'm thinking right now, what am I missing in this? Well, I'm missing this x. So if I multiply this fraction by x over x, then I'll have exactly the same denominator as that one. So that's exactly what I'm going to do. So I have x plus 2 times x over x plus 2 all over x plus 2. I don't know why I wrote those x's different, but anyway. So I have x all over x plus 2 plus, this stays the same, 2 all over x plus 2. So now what I have to do is bring these together over one denominator. So on the top, I add my numerators, x plus 2, all over x over x plus 2. Okay, so now I'm at the step, and I think, can I cancel anything? Can we reduce this down? Now remember, we only reduce if we have something exactly the same. So if we look at this, we have x plus 2 up top. We also have an x plus 2 in the bottom. So the numerator, x plus 2 in the bottom, so we can go cancel, cancel, and what we're left with is x 1 over x. All right, so that canceled it. Now let's have a look at our restrictions. Don't forget about restrictions. And generally what I look for with restrictions is to the factored form before I do any, just where I factor, then before I do any common denominators or flip and multiply or anything like that. So I look here and I'm thinking, what makes this denominator 0? So x plus 2 equal to 0. Well, it's pretty obvious. The only thing that's going to make this 0 is if x is equal to -2. So what we can say there is, first restriction is that x cannot equal -2. If we look at this one, we have the same thing here. X cannot be -2 for that one. But also for this one, we have this x hanging out here. So we got to recognize that if that x is 0, then this whole denominator is also 0. So we can't have x to be 0. So that's our final answer with our restrictions, and that will get you full marks on your common exam. All right, so here's another example where we're subtracting this time, and we have a slightly more complicated complex trinomial here to factor. So generally when I have something of that nature, I might want to take it to the side and factor it, just so I have some workings there. I don't want to just get ahead of myself here. So again, this is something I mentioned in one of my other videos, that it's your preference, decomposition or Joe's method, whatever you like. So we multiply 2 times 3, so what multiplies to get us 6 and adds to get us 5. So 2 times 3 gives me 6. 2 plus 3 gives me 5. So my numbers are 2 and 3. So what I have to do now is divide by the coefficient. So I have 2 divided by 2, divide by 2. So that gives me my two numbers now are 1 and 3 over 2. So make sure at this step, guys, you're reducing your fractions. If you're not reducing your fractions for Joe's method, you will not be getting right answers. So now what I have to do is put it in factored form. So I have x plus 1 and 2x plus 3. So that's my factored form. So that's equal to now x over x plus 1 all over, times 2x plus 3. And you see that kind of, like generally with these examples, guys, when you factor, you're going to have something similar in this denominator as in that denominator. If you don't, maybe you want to go back and check. Not always 100% that's the way it is, but generally that's probably going to be the case. Otherwise, it's going to be hard to find common denominator. It's going to be something big and complicated. All right, so you're looking at this thing, and we followed the same process. What do I need in this denominator to make this one the same? So what I need here is an x plus 1. So I got to multiply this by x plus 1. So I do that now. This stays the same. Minus, I have this going to be multiplied by x plus 1 over x plus 1. And so now we do that. This time I'm going to skip a step. I'm going to put this all over one denominator right away. So I'm going to recognize that on the top I'm going to have x minus 3 brackets x plus 1 all over my common denominator now of x plus 1 times 2x plus 3 x plus 1 times 2x plus 3. So now what I had to recognize is at this step I'm going to distribute this so I can simplify a little bit more. I'm going to distribute through with a negative 3. So make sure that your signs change. If you do it at this step, you got to recognize that that's affected by the subtract sign here. That makes this whole thing essentially negative, so be careful. So I have x minus 3x minus 3 all over x plus 1 2x plus 3. And now I look and just simplify here. So x minus 3x, that's negative 2x minus 3 all over x plus 1 2x plus 3. And then the next step here is to, if you look here, this looks very similar, so they're both negative. So what I can do is actually factor a negative, and I'll have negative outside 2x plus 3, and then all over x plus 1 2x plus 3. So then I can get this to cancel with this, and I'm left with negative 1 all over x plus 1. So that's my simplified rational expression. So let's go back and have a look at what are the restrictions. So again, look at your factored form for the restrictions. This is my factored form. So here, what's going to make this 0? What's going to be a negative 1? And this is a little bit more complicated. So we're thinking 2x plus 3 is equal to 0. What makes that equal to 0? Well, take my 3 across. So I got 2 is equal to negative 3. And then I'm going to have x is equal to negative 3 all over 2. So there's my two possible values here. So x cannot equal negative 1 or negative 3 over 2. So that's my restrictions. So that's your complete answer. Hopefully that answers a few questions for you guys. And I'll wish you good luck with your studying.